Good afternoon, YouTube. As you can see, there's quite a lot of user guides that I've created, all with videos and demos. The last two that I've been working on has this multi-cluster OpenShift Kubernetes, where one cluster is OpenShift and one cluster is Kubernetes, and being able to use DNS through DNS queries to either, and most likely at this time, round robin between Kubernetes or OpenShift. And actually, it was really interesting. Today I did see a GitHub issue coming in where now the community is starting to want features like topology. They're going to want features like ratios, and that's cool. And that means that you folks are looking at this content and are starting to vision and starting to implement, and that's exactly what happens. And so, today we round robin, but there's no reason why we couldn't add, cool topology or GSLB type advanced features. It's just an expansion of the existing eDNS or external DNS CRD, right? And so it's a matter of adding something to the schema, adding the code, and off it goes. But today's demo, I have added something new, which I've tested before, and I'm getting quite a lot of traction, and there's quite a lot of questions. And this is this overall F5 solution. And so in this example that I'm going to demonstrate now, we're going to talk about multi-cluster using OpenShift Kubernetes with BIG IP DNS Failover with, of course, the NGINX Ingress Controller. And so you could almost call this a 2-3 type architecture or a 2-tier architecture. It depends upon how you want to break up the DNS piece. And if you take a look at the architectural diagram, the 2-tier architecture is really BIG IP traditional type NetOps environments, which is configured potentially by the NetOps persona, the BIG IP manager. Maybe that person has some access within Kubernetes environment, etc. And then, of course, the second tier type is all of the DevOps application deployment, all of the pod deployment is kind of happening here. It's completely independent of what goes on with really routing to the cluster, routing between clusters, providing the Kubernetes or OpenShift connectivity, and providing application availability or potentially active type environments or active standby type environments. It really depends upon your application. And so that's what I really like about this. And I think that, to be really honest with you, this is probably one of the architectures that I see as kind of moving forward, where most organizations kind of blend really well. And I talk to a lot of customers here in product management, and this is kind of what I see. So I'd be interested to see and hear from you folks. Go ahead and you're welcome to comment in this video or send me an email directly and kind of let me know your thoughts, or if you want to set up a session, I'd be really interested to listen to what you guys are doing. So this is cool because here your NGINX environment, your NGINX Ingress environment, is front-ended by BIG IP. So BIG IP is really, if you think about it, doing forwarding from outside the cluster into the cluster itself. And so in this environment, this could be an on-prem and cloud environment, or it could be two on-prem environments. It really doesn't matter. We're platform agnostic in this case, and so we don't really care too much. However, there are some differences with configuring, for example, OpenShift in Kubernetes versus configuring OpenShift versus configuring NGINX in OpenShift versus configuring NGINX in Kubernetes, and something a little similar with CIS if you're using the operator, and some of those things I've called out here. But again, it's a single wide IP, so it's not necessarily per app. It's potentially maybe multiple apps sitting behind a single wide IP, and you can create multiple wide IPs here. You could create cafe A, cafe B, and they could have multiple endpoints. It really doesn't matter. I'm not restricting or limiting you to one IP. You can actually create multiple public IPs, and each public IP could have multiple endpoints. Just this is one example that I've done here, where I have one public IP, cafe.example.com, with two endpoints, both coffee and tea. And so the DNS monitoring is actually monitoring both of the endpoints. If one of the endpoints fails through a monitor, it will remove the wide IP and therefore not provide you to that site. So you can see right here in this example, I'm connected to 10.244. Now, if you know that is a flannel address, and if you know Kubernetes, you're going to know that was Kubernetes. Interesting, now it's 129, which is actually kind of cool. So I left it for a few, it timed out, and it went to 129. If you know 129, that is actually a OpenShift address. So I actually think that's kind of cool. So you could almost see how the round robin worked there. In connection first was connected to Kubernetes, one of these backend pods, and then when I requeried, it round robin to one of these pods. So that's kind of nice. I mean, that really shows something like an active environment. Both sites are active necessarily, right? And that's pretty much what organizations would want to do. You might ask me why Kubernetes OpenShift? Why not, right? I didn't make this stuff up, folks. I actually got this demo use case from one of my consultants over in Europe for a customer that he's working with. And he basically said that one environment is OpenShift and the other environment is a different type of Kubernetes flavor, and can I document it and so that he can present it. And so that's why I've done this, and I've seen this actually in a couple of places. So let's take a little bit of a closer look at this. So we talked about the architecture. We talked about it being potentially maybe a 2-3 type architecture and why with the different personas. I think that works quite well. We talked a little bit about why to do this. Let's go look at some of the configuration guidelines. So a couple of quick parameters. NGINX configuration for OpenShift is different than Kubernetes. So obviously take note. I've provided links, etc. My big IP DNSs are on the same device. It doesn't really matter. You can be on different devices, same device, it's up to you. I have configured an iQuery mesh. So that means that all my big IP DNSs share information. They sync with this iQuery mesh. It's just the protocol that we use, so we know that DNS in OpenShift can determine the health and status of DNS in Kubernetes, and that's kind of how the mesh works. Get into that a little bit more in a different session. So very simple here in OpenShift, deploy CIS. We're deploying it using a manifest. We've got some arguments here. You can see big IP and GTL on the same device. We're using a specific CNI, so that's pretty straightforward. We've covered that quite a bit. And then, of course, deploying NGINX in OpenShift, we're using the NGINX operator. You can actually see the operator is created here. And then once we create the operator, we'll create a simple manifest. And that manifest, think of it as a deployment. Super simple. I mean, I really like what they've done. I heard that they might be making some changes here, so just keep an eye out for this. But you can see there's the operator service, or there is the actual controller right there, and there is the controller. So this is the operator and the controller. Notice that this is our service. So that's actually really interesting. I initially thought that it was running on node port, but it's actually not. There's actually a trick in there. They're doing some type of, maybe, I hate to say the term, but spoofing of the IP. I was a little bit concerned that I was going to have to use this in node port, but no, this is actually using cluster IP. For some reason, they've created that, they create that service. And if you actually look at that service, you can actually see it. and that service is actually using cluster IP, which was actually really cool, because if you can see the IP, that IP there is not a node port IP address. That is a cluster IP, which is really nice, which is exactly what I wanted. And so that was actually the configuration of the NGINX Ingress Controller and OpenShift. So it was pretty trivial. Deploy CIS in Kubernetes, very easy. Deploying NGINX in Kubernetes, it's really, really, really easy. You can use the operator if you want, or you can just deploy a manifest. In my example, I just deployed the straight manifests. It's fine, doesn't really matter. Then I deployed the two different cafe applications, one in OpenShift and one in Kubernetes. OpenShift, because I'm using 4.9, it uses 122. I had to update the API changes. But in Kubernetes, since I'm using 119, I use the beta. And you can see that by going into these examples. So here's kind of where I want to go and spend a little bit of time, because the previous stuff is well covered by other demos and examples. But this is kind of new. So the use case here is to have a secure connection. So secure connection from the outside through BIG IP to NGINX. So it's secure all the way through BIG IP to the cluster and into the cluster. We make sure that if someone does generate an unsecure, it's redirected to secure using a 302 redirect. Also to have HTTPS monitors, you can actually see to have the HTTPS monitors all the way through. So the HTTPS monitors for LTM or local traffic, and the HTTPS monitors for the external DNS or the DNS project. We're also using the same host name for OpenShift and Kubernetes, but what would be different is they've got different public IPs. They're two different environments. They're on two different network spaces. Of course, that's the only way this is going to work. They have two different public IPs. They look very similar, but the third octet is different. One is 125 and one is 75. So pay attention to that. So you can see the host group of cafe, which allows me to kind of reuse this host in multiple different places. You don't really need it because we're not reusing the IP. So you could kind of take it out if you want, or you could leave it there, especially if you wanted to reuse that IP. Do we require the host group of cafe? Because we've got two different environments here. That's the only reason why I left it there, is if you want to reuse that IP for something else, right? The thing that we're doing here is the redirect, and here's our TLS. So we're doing re-encrypt. I'm just using the default certs. I'm referencing client cert and server cert with the same host name. What I'm doing here is my eDNS. That's just my name. You'll notice that my namespace is NGINX Ingress, so that's the namespace that I'm watching. And that's pretty much it. My data center name. You'll notice here that the load balance method is round robin. Like I mentioned earlier, that is the current method. I did get an enhancement request today, so I'm going to look at that. That's going to be prioritized. So that's actually kind of cool, and we're getting some more feedback. The second method or option I need to prioritize based on some information from the sales community. So that's really OpenShift. And to be honest with you, Kubernetes is exactly the same. The only difference is the IP will change and the data center will change. So we're using CRDs. I really like CRDs. Think of it as the child-parent relationship, that multi-tier. So the re-encrypt gets added to the virtual server, as you can see in the diagram. You can see there is the re-encrypt. And potentially if you want to add policy CRD, you could do that too. Those are children or sub-policies of the main parent policy. And you can see here's the eDNS. So create these. Don't forget you need the schema. This is an updated schema. It's pre-release 2.8. Just be aware of that. Let me know if you're going to play with this first, because this is unsupported stuff, right? Because of the monitors. This is a 2.8 feature. You see the one here and the other one. These are 2.8. So be careful. Don't deploy this in production until 2.8 is officially released. So you can see here virtual servers are running in OpenShift, and the TLS profile is created, and the eDNS statement is created, and you can actually see the virtual. So let's go take a look on the BIG IP. Since we're in there, I believe this is Kubernetes. Let's change it to the tenant. You can see here's the redirect. This is the this is the virtual. So if I go into the policy, I'm going to have two here. One is for tea, one is for coffee, and of course the different backends. You can see the backends here. This is NGINX running in Kubernetes, pretty simple. NGINX service. If you go to OpenShift, it's going to be a little different, just because of the service is somewhat different. So just follow my manifest files. Just because of the name of the service is different, because it's built on an operator. And so that's pretty straightforward. LTM piece is really straightforward. And this is in Kubernetes. You can see the only difference here is the data server, kind of where that's located. And here the IP is different, right? That's the only two. Other than that, it's almost exactly the same. So there is for Kubernetes, verify Kubernetes. Oh, okay, so let's go and take a look at step number 8 here, which is our wide IP. This is actually what we really care about. So if we go out to our DNS app here, we've got cafe.example.com. We've got 2 pool members. This is cool. This is what we want to see. So this is OpenShift and Kubernetes. It is a hash based on the day. Unfortunately, we should have put the pod or the location in there, but I got to talk to Dev about that. But in any case, you see 10 and 29. I believe 10 is, I can tell from the member here. Yeah, 10 is Kubernetes. So go look at the list here. So 10 is Kubernetes and OpenShift. So you can see there's one member in each. So there's one virtual, they're both active. So if I refresh this, let's see where it goes this time. Perfect. It went to Kubernetes, which is exactly what I wanted. So that is good. So what I'm going to do is I'm going to actually go ahead and fail one of these. I'm going to fail number 10. And so how I'm going to do that is I'm going to replicate that Kubernetes, I'm going to replicate that. I'm going to scale that pod down. So here we go. So replicate, let's change this to, there's 2 replicas in Kubernetes and I'm going to change that to 0. So what I'm going to do is I'm going to replicate NGINX down to 2, down from 2 to 0. If I want to see, there should be 2 here. Look at that, right? There's 2 pools here, and the pool member is green. So the first thing that will fail is the pool, and then the wide IPs. So let's replicate those down. Let's press enter on here. So there is currently a 2, and I'm changing that replica to 0. So there you go. And so if I do a kube ctl get pods, nothing. They've been replicated. So they were running. The deployment is still there, but the replication is basically set to 0. So when I go to polls here, you'll notice it's gone to red. Members is 0. Ouch. And that correlates. That service discovery, that's what CIS has detected. So CIS has detected that those apps are down. Now the pods behind NGINX are probably still running, and I can validate that by doing a kube ctl get pod, and you can see coffee and tea still running, right? So all of that access is fine, but the NGINX within that environment is not. So but also, if coffee had failed, if I had replicated coffee, the same behavior would have happened. But in this case, I just replicated the proxy. So this is not only testing the cafe and tea, but it's also testing the NGINX Ingress Controller. So any one of these potentially, and I can show you that further in the demo if we get time. So what you'll notice now is DNS GSLB. There's still 2 here. One of these pool members with, for example, 10 Kubernetes is red. So remember I had connected to it before. If I refresh this, right there, and so it went directly back to DNS, And if you look at the logs and go under the statistics of the wide IP here, let's go to DNS, and I want to pull statistics. I should have seen actually some stats here. That's kind of, auto refresh 10, okay. Okay, so this environment is not seeing anything. It's kind of surprised. I should have seen some DNS stats here from the wide IP. I should have seen some stats. OCP's got 2 connections, but I was quite surprised. I should have seen some A record stats there. Persistence method, preferred virtual server. Okay, so any case, so that's that. That's kind of how the failover has worked there. If you look now at the, you can still see that that's failed. So let's bring that guy back up again. So let's fix that replica. Let's change this to 2, and we'll change this to 0. So now basically we're going from current of replica of 0 to 2. So we're bringing back up the back end, which is kind of nice. So the first thing we'll notice is in local traffic management, CIS will detect those pools. So nothing's happened yet. I can get the status of those. So I can, so those are running. There's their IPs. And so all members, very nice. There's their IPs. There's the 2 pool members. So the pool is up. So the virtual server is back there. And this DNS, it might take a, see, it should be green, green, green. And so now if I try, I'm back in Kube. And if I go back to the statistics, let's see if I'm seeing anything on the stats here. Interesting. Quite like that. Let's, any case, wide IP normalization. Let's see, do I see anything at the pools? 0, so maybe there's no active connections. And so that's, these should all be active connections. This is all Kubernetes. And if I go to coffee as well, it's going to be the same. I don't have to resolve DNS, so it'll just to that back end. So there's coffee again. So let me just let me do an auto refresh on this, and an auto refresh here. And so this will refresh in 1 second. Let's see what we see here. Hopefully we'll see something. No, these are real short-lived. So in any case, that's the monitor. So now that we saw that these are up, let's go and fail one of the apps. Let's see what happens if we fail one of these applications. So instead of replicating, so we've got coffee here of 2 and tea of 3. So let's do a 2 here, and we'll change this to a 0. You know what, let me change it to 3. So it's going to be 3 and 3, so that will actually be easy. Then I won't have to mess around with this too much. And this is going to be coffee. And this is no namespace. There we go. So what I've done is I've said just replicate that from 2 to 3, get those pods. So now we've got 3 with 3 of each. Cool. So now what I'm going to do is I'm just going to say 3. So I'm going to fail the back end, and I'm going to change this to a 0, and I'm going to deploy. So what I'm doing is I'm taking it from 3 to 0, and I'm going to do the same for T here. And so take a look at my pods. My pods are terminating. Take a look at BIG IP here. Now on Big IP, will I see those pods? Will I see the pods? I will not. And the reason why I won't see the pods is because Big IP has no visibility. This is DevOps. So this is actually kind of nice, because imagine if you had thousands of these pods, right? And this is really good, because if you had 1,000 pods, then then the API is updating Big IP every time a developer does something like this. So this is why it's really nice where your Big IP or your first tier is really stable, and the API only changes when you replicate an Ingress controller. But at this state here, I'd have to go and look at the Ingress controller to actually see what's the state of these pods. I can see the state of these pods because the Kubernetes API will tell me. And so if I look at the wide IP, the wide IP is going to be quite interesting. Let's take a look at this. Aha. Why did it fail? That's interesting. And if you ask me why did it fail, well, I can show you that they have these monitors here. And so if we go look at this monitor, this monitor is actually monitoring the backend application. And we actually took down tea and coffee. And this is an SNI based monitor, because you can actually see there is the SNI. So it's an SNI based monitor that failed. And so that's why the application went down. So there's absolutely no reason why I should give out. You can see, go back to DNS, and here as well, go back to DNS 129, 129, so 130. So back to DNS right here. So if the app fails, then we remove the wide IP and load balance you to an environment that is available. And so this is not only just providing the DNS service, also just for the Big IP and what's in the Big IP's pool member being NGINX. This is actually also monitoring the backend application, and that's why we moved it to monitors, to allow us to do both per app as well as single host name with an app. Just make sure you talk to your F5 solution architect, your F5 consultant, your F5 sales team about scaling, right? Because it all depends upon the health of how many of these monitors you're actually sending out, right? So, but that's actually really cool. And so that kind of shows both methods, whether I fail the NGINX Ingress Controller, replicate it down to 0, or if I replicate the app that sits behind, because this monitor is going end to end. It's a true health and status of the application. And so that's kind of what's going on here. And CIS is doing all of that automation. So let's go back to the architectural diagram and just do a quick summary. So the summary here is that we have multiple environments, one in this case being Kubernetes, one being OpenShift. It doesn't really matter what you have. And what you want to do is you want to potentially do some type of active between these two. And what I'm doing here is I'm round robining between the two environments. But there's other methods that potentially could be done. It's just that we started with round robin. We're trying to get the community to do some testing, etc., and get some more feedback. But with this now, as you can see, I kind of failed one environment, and I'm always able to get access to the application. These are two mirrored applications. They're identical. I'm always able to get either one or the other based on either one location or the other location. And so if you're not sure whether you want to do Kubernetes or OpenShift, or you have another environment right now, you don't want to tear it down and you want to build something else, but you want to do load balancing between the two and you've already got Big IP, this is like a perfect example of where you would want to use this type of architecture. Hope this has been useful. Please subscribe to my channel. There's lots of cool stuff coming. I've got a list of videos from requests that I am working on, including migration, to some more Ingress link stuff coming up next, to some other cool stuff that I want to do in the future. So like, subscribe, share the channel, give me some feedback. What other kinds of content features do you require? If this is useful, if this is not useful, that would be helpful as well. Really appreciate it. Have a wonderful week, and enjoy your afternoon. Thank you.